So in the first experiment we have a few different liquids: water, soap, alcohol, and oil. Each one of them has a different density. And if the difference in densities is great enough, the different fluids should not mix. Look at what we just did right here. So the green liquid that you guys are seeing right now is soap. This soap has been diluted with water so that its density is not really different from the density of water. You can see when we add the water in, we don't see a clear difference because of the similar densities. So the density of oil is notably less than the density of water. So when they're mixed together, you can see a clear difference between the two liquids. Similarly, alcohol has less density than oil, so the same thing happens. Now that we know the density affects where a fluid is placed in a mixture, with the densest fluid at the bottom and the least dense at the top, we're going to see how this relates to temperature in experiment 2. As you can see, we've colored the cold water blue and the warm water red, and we placed the warm water above the cold water. When we remove the piece of paper separating them, they mix slightly, but they don't mix completely, and the red stays above the blue. This is because warm water has a lower density than cold water and stays where it is. In the third experiment, we reversed the process. We placed the warm water on the bottom and the cold water on the top. Because warm water is less dense than cold water, it tends to float towards the top. This causes the inevitable mixture of the two fluids and their colored molecules.
It spreads way faster because great.
Well,
But it might work.